Hi and welcome to Chemipedia chemistry classes for 11th and 12th standard. So in this video I am going to discuss a simple trick to find bond order. How to find bond order of a molecule. So first let us see what is the definition of bond order. So bond order definition, it is half of the difference between number of electrons in bonding molecular orbitals, that is BMO, to anti-bonding molecular orbitals, ABMO. So it's nothing but difference in number of electrons between bonding molecular orbital to anti-bonding molecular orbital. So this is a formula. Bond order is equal to electrons in bonding molecular orbital minus electrons in anti-bonding molecular orbital divided by 2. So simply formula given as NB minus NA divided by 2. So this is nothing but a simple molecular orbital diagram for a molecule. Okay, so we start with 1s orbital. When a 1s orbital of an atom combines with 1s of another atom, so you get molecular orbitals as sigma 1s and sigma star 1s. Okay, so in both ends what I have written is nothing but atomic orbitals. These are nothing but atomic orbitals, AO. Then the sigma 1s, sigma star 1s, what is written at the center is nothing but molecular orbital. When atom combines to form molecule, atomic orbitals are converted into molecular orbitals. Okay. The 1s atomic orbital combines gives sigma 1s and sigma star 1s, one with lower energy, what you called as bonding molecular orbital, another one with higher energy, anti-bonding molecular orbital. Similarly, when 2s atomic orbital of one atom combines with 2s atomic orbital of another atom, so we get two molecular orbitals. One is sigma 1s, sigma 2s, another one is sigma star 2s. So the lower one bonding molecular orbital, the higher one anti-bonding molecular orbital. Similarly, when 2p orbitals of two atoms combine to form a molecule, we get molecular orbitals of two sets, BMO and ABMO. So bonding molecular orbital about 3 number and anti-bonding molecular orbital about 3 number, isn't it? So I have given the symbol. The bonding molecular orbitals are given symbol pi 2py, pi 2pz with same energy drawn together, sigma 2px. Similarly, corresponding anti-bonding molecular orbital pi star 2py, pi star 2pz, the other one sigma star 2px. Okay, so that when 2p of one atom combines with 2p of another, we get 3 bonding molecular orbitals and 3 anti-bonding molecular orbitals. Okay, this is a number you have to remember. Okay, so before we go to find out the bond order, we should have the basic idea about this. Okay, what is molecular orbital, what is bonding molecular orbital, what is anti-bonding, what is the formula for bond order, etc. Okay, right. Now, so simplest example, let us see how to find out bond order of hydrogen molecule. Okay, right. Hydrogen atom electronic configuration is 1s1. It has only one electron which is placed in 1s orbital, isn't it? So this is electronic configuration of one hydrogen atom. This is of another hydrogen atom. Okay, right. Then when these two hydrogen atom combines, you get hydrogen molecule, isn't it? So the molecular orbitals are drawn at the center. One molecular orbital is given with a symbol sigma 1s, another one is given with a symbol sigma star 1s. Okay, whereas 1s orbital of one hydrogen atom has one electron, 1s1 electron. This is 1s1 electron of another hydrogen atom. Now these two electrons are filled in molecular orbital like this. So 2 electrons are there totally, so that they are supposed to be filled in sigma 1s orbital itself. Sigma star 1s will be empty now. Okay, now from this you can calculate the bond order of hydrogen molecule. Then the diagram what is drawn here is nothing but molecular orbital diagram. Bond order formula NB minus NA divided by 2, isn't it? The number of electron in bonding molecular orbital, this one 2. Anti-bonding no electron at all, isn't it? So that NB place I substitute 2 and the Na is 0 divided by 2, 2 by 2 I am getting 1. So which means that in hydrogen molecule the bond order is about 1. Okay. Or otherwise you can say in hydrogen molecule there is a single bond exists between two hydrogen atoms. Okay, H single bond H. The next example, lithium molecule Li2. So lithium electronic configuration, atomic number 3, so that it has configuration 1s2 2s1, isn't it, right? So this is one lithium atom, this is another lithium atom. So electronic configuration 3 electrons, isn't it? So 1 2 3 electrons, then 3 electrons of another lithium atom. Okay, right? Actually, so this belongs to sigma 1s orbital, these two electrons belongs to sigma star 1s orbital, then this comes under sigma 2s orbital. Now we can calculate the bond order by considering only the electrons present in outermost orbital. Okay, so here the outermost orbital sigma 2s and sigma star 2s. Sigma 2s is bonding molecular orbital, sigma star 2s is anti-bonding molecular orbital. Bond order Nb minus Na divided by 2. The number of electrons in bonding molecular orbitals. Number of electrons in bonding molecular orbitals is about 2, isn't it? This one. But 2 minus anti-bonding empty, so 0 divided by 2, so that you are getting 1, isn't it? So that the bond order of lithium molecule is about 1. It's a very simple method to find out bond order of molecules. Okay, right? The next one I have given boron as example, B2 molecule. Okay, boron electronic configuration, it has atomic number 5, so that 1s2 2s2 2p1. Okay, right? Now, so boron configuration, 1s electron, these two are 2s electron, then this is 2p electron. Okay, right? Now so after combination, so that these are the two electrons which are filled in sigma 1s orbital, this is sigma star 1s. Similarly, these two are sigma 2s electrons and sigma star 2s electrons. Then last 2p orbital, so the 2 electron will be placed in pi 2py orbital. Okay, right? Now here the anti-bonding or molecular orbital will be empty. The 3 anti-bonding molecular orbitals will be empty. Okay, right? So outermost orbital, so this is bonding molecular orbital. So number of electron in bonding molecular orbital is about 2. Anti-bonding molecular orbital has no electron at all. So Na value is about 0. Right, now I substitute in the formula Nb minus Na by 2. So that number of electron in bonding molecular orbital 2 minus Na 0 divided by 2. So I am getting 1. Okay, but therefore the bond order of boron molecule also nothing but 1, like hydrogen and lithium. Okay, right? So next one, carbon molecule C2. What is it? C2 molecule. Carbon atom electronic configuration 1s2 2s2 2p2, because it has atomic number 6, isn't it, right? So this is one carbon, this is another carbon atom. Now it combines to form carbon molecule, isn't it, right? Now that 6 electrons are placed in the molecular orbitals like this, sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, whereas bonding molecular orbital p orbital, so totally 4 electrons are there, isn't it? They are placed at pi 2py and pi 2pz orbital. Okay, now in carbon molecule the anti-bonding molecular orbital will be empty. The pi star and sigma star orbitals will be empty, so they do not have any electron at all. Okay, right? Now the outermost orbital electron Nb is equal to 4, isn't it, right? Now I substitute in the formula Nb is 4 minus Na 0 divided by 2, so that I am getting 2. So therefore carbon molecule bond order is about 2. Okay, so first 3 molecule hydrogen, lithium and boron bond order is about 1. Now so for carbon we are getting about 2. Okay, so the next example is nitrogen. So nitrogen atom electronic configuration 7 atomic number, so 1s2 2s2 2p3. Okay, so I have written the electronic configuration and I have filled the electrons in molecular orbitals. Okay, even in nitrogen also the anti-bonding orbital which is formed by combination of p orbital will be empty up, so that Na value will be equal to 0. Okay, so this is pi star 2py. So next one pi star 2pz, the last one sigma star 2px. Okay, right? So now let us substitute in the formula. So bond order Nb minus Na by 2. The number of electrons in bonding molecular orbital 6, Na value 0, 6 minus 0 by 2, so I am getting 3. Therefore bond order of nitrogen molecule is about 3. Okay, right. Then the other example, oxygen molecule. So oxygen atomic number is 8. So electronic configuration 1s2, 2s2, 2p4, isn't it? Okay, right. Now this is a molecular orbital diagrams, simple format. So oxygen, there are 4 electrons in p orbital. There are 4 electrons in p orbital. So that totally in oxygen molecule 8 electrons in p orbital together, isn't it? So they are filled in molecular orbitals like this, in which bonding molecular orbital carries 6 electrons and anti-bonding with 2 electrons, isn't it? So that when we substitute in the formula, Nb value 6, Na value 2 divided by 2, 4 by 2, so 2. So therefore the bond order of oxygen molecule is about 2. So which means in oxygen there is a double bond between 2 oxygen atoms. That is in oxygen molecule there is a double bond between oxygen atoms, isn't it? Likewise in nitrogen molecule, nitrogen bond order is 3, isn't it? So which means that in nitrogen molecule between 2 nitrogen atoms there is a triple bond, okay, because the bond order is equal to number of bonds, you know very well, isn't it? Right. Then the next example, heteronuclear molecules such as carbon monoxide, okay. So here carbon electronic configuration is this one. Then similarly I have given the configuration of oxygen also. Carbon configuration 2 plus 2, 4 plus 2, 6, isn't it? Then oxygen configuration, totally 8 electrons are there. So 2 here, 2 more 4, 5, 6, 7. The 8th electron of oxygen I have drawn it here. It is getting filled in that bonding molecular orbital itself. Okay, that's why I have written with a different color. Okay, right. Anti-bonding orbitals are empty in case of oxygen. Carbon monoxide. What is it? In case of carbon monoxide. So now I substitute Nb and Na values in the formula. So Nb is about 6, Na value 0, 6 minus 0 divided by 2. So 6 by 2 is nothing but 3. Therefore, carbon monoxide also has a bond order about 3. Okay, right. Then the next example, nitrogen monoxide. Next, almost the last example. What is it? Nitrogen monoxide, NO molecule. So nitrogen electronic configuration, oxygen electronic configuration. Now nitrogen and oxygen while combining, the electrons are filled in molecular orbitals this way. Okay. So you know very well that this is sigma 1s orbital. This is sigma star 1s. This is sigma 2s. This is sigma star 2s orbital. Then this is pi 2py, pi 2pz, sigma 2px. Likewise pi star 2py, pi star 2pz. The last one sigma star 2px. Okay, right. Nitrogen 7 electrons, oxygen 8 electrons, so that they are filled in molecular orbitals this way. Okay, whereas in the outermost orbital, the bonding molecular orbital BMO contains 6 electrons, and ABMO, anti-bonding molecular orbital, contains only 1 electron. So now let us substitute in the formula. Nb value 6 minus Nb is 6, Na is about 1, isn't it? 6 minus 1 divided by 2, 5 by 2. So bond order is about 2.5. Okay, I hope you are able to follow how to predict bond order of molecule by this simple way of writing electronic configuration. Okay, thank you. Keep watching my other videos also. Okay, thank you very much.